In Part 4, I introduced the flux material used in fire assay to pre-concentrate, collect, and refine your precious and noble metals. In this presentation, I will be expanding on those fluxes. The information presented is important in the calculation of the flux quantities used for the charges that you will be fusing. It is suggested that throughout this presentation, pause the video and jot down some of the important details that will be needed, or be free to download this presentation for future reference. Hi, I'm Rob Boyko, Boyko Mineral Exploration, and welcome back. Sodium carbonate is listed as a very powerful basic flux. It is also the least expensive flux used for a crucible fusion. When it melts, it becomes very fluid, such as it will hold a large amount of fine infusible and inactive particles in suspension, such as bone ash. It comes as a dry powder from a chemical supplier and must be kept in airtight containers to keep it anhydrous. This material has the tendency to absorb moisture. It can also be purchased from your local grocery store as a hydrated material, commonly known as washing soda, which is highlighted in blue hash in the slide, which you can dehydrate in your oven to make it anhydrous. Between 852 to 950 degrees centigrade, this material will not decompose appreciatively. Above the 950 degree mark, it will start to release carbon dioxide. The point to remember is that it is a base and an acid is required. The acid is the silicon dioxide, which in turn forms the sodium silicate slag. The product from the sodium nitrate is disodium oxide, which is the base. The sodium carbonate will decompose to disodium oxide, which in turn fuses with the silicon while the carbon dioxide gas is released. By adding the borax, the melting temperature will drop even further. Because these silicates are very fusible, they have the ability to create many complex silicates as well. Because they have the ability to form alkaline sulfates and sulfides, they can also be considered as desulfurizing agents. They can also be oxidizers. Lead oxide, commonly referred to as litharge, comes in a granulated and powdered form. It is classified as silver-free. However, there will always be a small concentration of silver. When this material arrives at the lab, it will always be tested for the silver concentration. As for a small prospector or small-scale miner, you will not be doing any critical analysis and therefore preliminary testing may not be considered. Litharge is readily fusible. It is basic and characteristic as well as desulfurizing and oxidizing as shown here. Regarding crucible fusion, it is used to supply globules of metallic lead. By adding flour, which is considered as carbon, it will reduce to elemental lead. The lead will alloy with the precious and noble metals that may be present in the sample or concentrates. This is the collection part of the process. It is also used to form the slag with the acidic flux, which is the silica and borax. The result is the formation of the lead silicates. The melting temperatures are lower than the base silicates. It is for this reason that the lead oxide is always or almost always added to every crucible fusion. Litharge has a great affinity for silica. If there is not enough silica in the mix, the litharge will attack the acidic component of the crucibles. This may cause a hole to be eaten through the crucible during fusion. That is, if there's enough acidic material in the crucible being consumed by the litharge. Silica is the strongest acidic flux used. When subjected to high temperature and it starts to melt, it readily combines with the metal oxides to form silicates. This is actually the foundation of all slag material. Calcium sulfate, when heated, eventually breaks down and forms calcium oxide. Limestone is calcium carbonate. it too breaks down to form calcium oxide. The two dots in the formula simply means that this is a fused silicate of calcium oxide and silicon dioxide. The amount of silica used is calculated for each element making up your ore or concentrates, less the precious and noble metals. Because of its acidic property, it also serves to protect your crucibles from the corrosive action of the litharge. But too much silica will lead to a loss of the gold and silver, etc., due to slagging and the formation of a matte layer, which will be explained in another presentation in this series. Borax can be purchased in both states, one containing water molecules and the other without, commonly referred to as being anhydrous. You can purchase borax off the shelf at your local supermarket and drive the water off yourself in your oven, or you can purchase it from your chemical supplier as a higher grade of borax glass. Once the water of crystallization is removed, the resulting product can then be pulverized to a powder, resulting in the glassy borax glass. Once the borax has been turned into the fused anhydrous tetraborate, it must be kept in airtight containers, as it will start to absorb moisture, and moisture is not what you want during the melting process. Borax is used in almost every crucible fusion. Due to its lower melting point, the slag formation temperature is also lowered, which facilitates the slagging of the sample. It is also an excellent solvent during the fusion process. At red heat, it becomes a strong acid which will dissolve almost all of the metal oxides in the alkaline earth carbonates, such as calcium carbonate, etc. It is also one of the best fluxes for the alumina complexes. Alumina simply stands for aluminum. Too much borax in the mix will cause the resulting glassy slag to be extremely tough. It will cling to the lead button, and during removal, some of the lead and collected precious metals would be torn away with the slag during separation. A matte may also be formed. Matte will be discussed in a future presentation. Borax is also used as a cover layer on top of a charge. This minimizes the mechanical loss of the precious metals due to spitting caused by a rapidly escaping vapors. Although the chemical name for lead is plumbum, in the periodic table it is usually listed as lead, its common name. Like the litharge, it must be silver-free. For analytical analysis, every new batch must be tested for the silver concentration and recorded. Lead, for our purposes, is purchased in two flavors, granulated test lead and lead foils. Granulated test lead is used in scorification, and the lead foil is used in inquartation and bullion testing. It too is used as a collector for the collection of the precious metals. Scorification and inquartation are two separate presentations that will be presented later in this series. Inquartation is part of the refinement process for your gold door beads. Scorification is an alternate fusion process. Although the chemical name is somewhat extreme, it is only baking flour. The organic, untreated, or non-fortified variety is best. It is inexpensive and considered to be carbon, much cheaper than granulated charcoal. It is used to reduce the litharge to metallic lead. As shown, 12 molecules of lead oxide, when mixed with the flour and fused, during the fusion reaction the litharge is reduced to 12 molecules of metallic lead, and the rest is carbon dioxide and water vapor. Unless there is a need for charcoal, the flour is the go-to replacement and is used almost all of the time. Charcoal is made up of 93% carbon, 3% ash, and the rest is oxygen and hydrogen. During fusion, some of the carbon, all of the hydrogen and oxygen is expunged as water vapor, carbon dioxide, carbon monoxide, and the ash will be slagged. Remaining will be the carbon. Because it contains 93% carbon, it is considered to be and is labeled as activated carbon. It is for this reason it can be said that the charcoal will have a molecular weight of 12.0 grams per mole versus the 140 grams per mole as shown. It is said to be the strongest reducing agent available, but due to cost, flour has become the substitute. During fusion, it has been shown that charcoal will react with any available oxygen, resulting in the two gases and water vapor. The remaining elemental carbon will react with the litharge, reducing it to elemental lead. Iron is not only a reducing agent, it is a desulfurizing agent. Adding iron to your sulfide ores such as galena, argentite, sphalerite, chalcocite, cinnabar, and a few others, the sulfides will decompose, forming iron sulfide complexes. However, sulfides that contain copper, such as chalcocite, millerite, which is nickel sulfide, and sulfides of cobalt, will only partially be desulfurized. Oxides will be reduced by the iron, such as the lead oxide that is used as a collector when reduced to elemental lead. As shown in the slide, galena is desulfurized to elemental lead, and the litharge is also reduced to elemental lead and forming a mineral called wüstite, which is a mineral usually found in meteorites and native iron, many times confused as being rust. Potassium nitrate, commonly referred to as niter, is a very powerful oxidizing agent. It is used in crucible assays to inhibit the amount of lead that is reduced from the litharge during the fusion process. It is also used to reduce the sulfide complexes of the base metals such as lead, copper, zinc, etc. Besides being an inhibitor, it is specifically used to oxidize the arsenides and antimonides besides the metallic sulfides such as galena and sphalerite. Niter is stable until it reaches a temperature of 400 degrees centigrade. When it starts to decompose, it will release nitrogen and oxygen gas. The end product becomes potassium oxide. Potassium oxide is a basic flux which will fuse with the silica to form the slag. Remember that in order to form a slag, a base is necessary to fuse with an acid, being the silica dioxide. The silver used as a reagent can be in a form of pure silver, such as silver powder or a wire, a silver alloy such as Hermann quartz, or as a silver nitrate solution. These are added when you are trying to perform your gold and platinum analysis, or for the collection and refinement of. Every new batch of silver should be assayed for the presence of gold and the concentration recorded. Even though the silver is considered to be pure, there may be some gold alloyed with the silver. Gold and silver appear to be married to each other. For any parting process, there must be an adequate silver to gold ratio. Anything less than 4:1 will result in an inefficient parting. Adding silver also aids in the reducing of the gold loss. All this will be covered in future presentations. Fluorspar is a neutral flux, but it has the ability to increase the fluidity of the charge, making it less viscous. If your sample contains more than 1% aluminum, this reagent is used. It has been also found to be useful in the slagging of ores that contain black sand, magnetite, and calcium phosphate. Calcium phosphate is also known as bone ash. Cryolite, as a pure mineral, will start to melt at about 1012 degrees centigrade. It is classified as a neutral flux and is considered as a good solvent. It is used for the refinement of aluminum. It is used to dissolve aluminum oxide. It reduces the melting temperature of the aluminum oxide from 2500 degrees centigrade down to about 950 degrees centigrade. If you have alumina in your ores or concentrates, cryolite will dissolve up to 25% of the alumina at temperatures less than 1000 degrees centigrade. Sodium chloride is nothing more than table salt. During fusion it will melt, but will not fuse with the slag. It is used as a cover layer to exclude the atmosphere, thus reducing the oxidation potential of the surrounding air. It also acts as a detergent in some ways, as it washes the sides of the crucible. It inhibits small particles of lead from sticking to the side of the crucible, therefore reducing losses of precious metals. As a top layer, it reduces the risk of boilover due to escaping gases as it floats on top of the slag. The old-timers used to call this acid aquafortis. It was also known as spirit of niter. These days, it's just called nitric acid, which is the chemical name. It has many uses, which will be discussed in upcoming presentations, but it's mainly used in the parting process in regards to the fine art of fire, which you now know as fire assay. It is sometimes sold as muriatic acid. It is also labeled hydrochloric acid. Not only used to create aqua regia, it is used as a dissolution solution. It is also used to partially neutralize nitric acid, as well as a precipitant. This will be discussed in an upcoming presentation. The old-timers called it royal water. The ancients referred to it as the king's water. Today, it is commonly referred to as aqua regia. It is prepared by mixing 3 parts of hydrochloric acid to 1 part nitric acid. This solution is a very strong oxidizing solution that will dissolve almost everything, and that includes the elemental gold and the platinum group metals. But when it comes to silver, it's not so effective. A minute amount of silver will start to dissolve. However, a chloride coating will start to form, which inhibits further reaction with the silver. It is this insoluble chloride coating which inhibits further dissolution of the silver. In Part 4 of the Fine Art of Fire, I introduce you to the chemicals, or reagents as they are called, that are used as flux material, which is mixed with the concentrates or samples for the pre-concentration, collection, and refinement of the precious and noble metals, included with some of the reactions that take place during fusion. In this presentation, I extended the information on the flux material by adding the usage and the characteristics that are important. The characteristics that one should be totally familiar with are the atomic weights and their formulas. These are used in the calculations that are used to determine the correct quantity and type of flux required to be mixed with your samples or concentrates. In the next presentation, which is coming soon, Part 6 of the Fine Art of Fire, I will have to discuss the types of ore or rock types that make up your sample material. There are 2 groups and 3 categories which will be discussed. I hope that you will find Part 6 interesting when it is published. As always, I have to remind you that this channel is purely educational and I do not advertise merchandise. I do not ask for patronage either. I just promote prospecting and mining as a small business or as a hobby. If you find these presentations helpful or just interesting, My only reward is that you give them a thumbs up or a like and a share. I thank you for watching. I am Rob Boyko, Boyko Mineral Exploration.